From supersonic jets to real flying cars, the future of aviation is happening faster than you think. These mind-blowing aircraft and machines will completely change how we travel, explore, and even live. Watch till the end and comment which futuristic technology impressed you the most. Passion Flying Cinematic. Alex. Passion Flying Cinematic. Alex skyrockets the idea of flight from hobby to cinema-grade obsession. Alex, a drone and FPV filmmaking wizard, crafts jaw-dropping aerial shots with custom-built rigs that slice through the sky like stunt fighters. His work literally turns clouds into movie frames. What's wild? His heavy-lift cinematic drones can hover at over 10,000 feet, stabilize on gusty mountain ridges, and capture breathtaking 8K footage that no traditional aircraft camera system could. This isn't just remote control, it's redefining how humans film the sky itself. Boeing 747 Dreamlifter. This weirdly bulging giant is no ordinary jumbo jet. It's the Boeing 747-400 LCF, aka the Dreamlifter, built to haul parts of the 787 Dreamliner across continents at blinding speeds. Its massive cargo bay can hold 65,000 cubic feet of load, 3 times more than a standard 747 freighter. Imagine ocean freight taking 30 days. The Dreamlifter can slash that to under a day. It's a flying warehouse, up to 150 tons or more of oversized cargo, and a maximum takeoff weight of approximately 364,000 kilograms, approximately 803,000 pounds. This beast doesn't open its nose like other freighters. Instead, its tail swings open, like a sky-sized dump truck, to swallow entire airplane wings. Virgin Galactic. Virgin Galactic is rewriting the rules of flight. It doesn't just fly, it soars into space. Launched from a high-altitude mothership called VMS Eve, its rocket-powered spaceplane, Spaceship Two, VS Unity, is released at about 45,000 feet, then ignites a hybrid rocket motor to blast passengers upward. The Unity reaches the edge of space, roughly 80 to 90 kilometers, 50 to 56 miles, giving flyers a few precious minutes of weightlessness and an unmatched view of Earth against the blackness of space. A single Virgin Galactic seat can cost upwards of $450,000 to $600,000, making it one of the most expensive joyrides on Earth, or above it. Aurora X65 crane. Get ready for a total mind warp. The Aurora X65 isn't just an experimental plane. It's a decapitation of over a century of aeronautical tradition. Instead of flaps, rudders, and moving parts, this DARPA/Boeing prototype controls flight with jets of air, slicing through the skies with no visible flaps. This small, unmanned 7,000-pound, 30-foot wingspan craft is designed to fly at Mach 0.7, think trainer jet speed, but with literally no hinges. If successful, X65 could completely eliminate traditional control surfaces, rewriting how planes are designed, built, and flown forever. Hard Aerospace ES-30. Hard Aerospace is flipping regional aviation on its head. Their 30-seat hybrid electric airliner, the ES-30, can fly pure electric for approximately 200 kilometers, switch to hybrid mode for approximately 400 kilometers, or push up to approximately 800 kilometers when lightly loaded, 25 passengers. It charges in about 30 minutes and can take off and land on runways as short as 1,100 meters, making it a perfect fit for small and remote airports. This plane could make electric short-haul flights the norm, slash carbon emissions, and open up routes airlines once thought impossible. And that's before it even flies commercially. Boom Symphony Supersonic engine. Brace yourself, the Symphony engine is Boeing Supersonic's radical reboot of what propulsion can be. This twin-spool, medium-bypass turbofan pushes out 35,000 lbf of thrust at takeoff and is built to sustain supercruise at Mach 1.7, all without messy afterburners. It's optimized to run on 100% sustainable aviation fuel, SAF, with a passively cooled high-pressure turbine and a smart variable geometry nozzle that keeps noise lower than prior supersonic jets. Symphony's design could slash maintenance costs by up to 10%, while delivering a 25% longer service life, potentially rewriting economics for supersonic travel and making the Overture airliner commercially viable for the first time. Seadragon rocket. The Seadragon is a mind-boggling Cold War-era concept. A 150-meter-tall, ocean-launched mega rocket meant to haul 550 metric tons into low Earth orbit, a payload size that even today's Starship only dreams of. It was designed to be built from cheap shipyard steel, to be towed out to sea, submerged upright, and fired off the ocean surface. No launch pad needed. It would have needed a thrust of 350 million newtons at liftoff, enough power that launching from land would have literally ripped apart any terrestrial launch pad. Airbus Vahana. The Airbus Vahana was a jaw-dropping leap into the future of urban flight. A single-seat, all-electric tilt-wing eVTOL demonstrator that could take off vertically, transition into forward flight, and land itself, completely pilotless. Powered by 8 electric motors, each approximately 45 kilowatts, the tiny craft tipped the scales at approximately 815 kilograms maximum takeoff weight, could cruise at approximately 190 kilometers per hour, and flew 138 test missions before the project wrapped up in late 2019. Vahana was never meant to become a commercial flying car. It was a technical experiment to prove self-piloted electric flight was even possible. Yet today, the autonomy, detect and avoid tech and tilt-wing lessons it pioneered are literally shaping tomorrow's airborne taxis. Laser in-flight communications. Picture streaming Ultra HD video from a jet midair, not via Wi-Fi or radio, but through a razor-thin laser beam pointed straight at space. That's the future of laser in-flight communications. These optical links can hit data rates well above 1 gigabit per second, with theoretical speeds up to 10 plus gigabits per second, vastly faster than any traditional radio-based system. But here's the twist. Laser beams are incredibly sensitive to fog, clouds, and atmospheric turbulence. A stray cloud or a shift in air density can interrupt the beam and knock the connection out completely. If laser links can be stabilized mid-flight, the sky could become a streaming superhighway, turning every aircraft into a moving data relay capable of downloading terabytes of information at lightning speeds. Zeppelin airships. Zeppelins are the slow-motion titans of the sky, massive, rigid airships filled with helium, floating more than flying. Historic giants like the LZ-127 Graf Zeppelin could carry payloads of approximately 15,000 kilograms across approximately 10,000 kilometers, cruising at roughly 120 kilometers per hour. Today's Zeppelin NT Neue technology models are semi-rigid, quieter and far safer, built with carbon fiber and aluminum frames. They can take 12 to 14 passengers on long, stable sightseeing flights, hover steadily for hours, and offer ultra-low vibration rides. Zeppelins don't just cruise the skies, they could usher in a new era of ultra-efficient, runway-free cargo and surveillance platforms, quietly floating above polluted city centers or disaster zones long after conventional aircraft have left the air. SEOS/MIT Electra, Electra's SEOS, Stratospheric Airborne Climate Observatory System. Project is a jaw-dropping solar electric aircraft network built to fly months in the stratosphere, collecting climate data that satellites simply cannot. These unmanned Dawn 1 planes, at approximately 90 feet wingspan, can hover high above storms, ice sheets, and wildfires, measuring aerosols, ozone, and atmospheric chemistry with ultra-high precision. SEOS could forecast climate disasters before they erupt, like glacial collapses or megastorms, giving humanity a chance to respond in real time. Quarter-horse Mk-1. The quarter-horse Mk-1 is not your average drone. It's Hermeus' audacious step toward hypersonic flight, packing a GEJ-85 jet engine, yes, the same one used in older fighter jets, into a sleek, uncrewed high-speed testbed. Its mission? Nail down remote takeoff and landing at blistering speeds, typically the hardest parts of flight for ultra-fast aircraft. Quarter-horse Mk-1 went from drawing board to flying in just a year, heralding a radical new pace for aerospace development. What's next? Mark II, aiming for supersonic flight, and Mark III, chasing SR-71 level speeds. Jet Zero's Z4, airplane. Jet Zero's Z4 is a flight world bombshell, a sleek, blended-wing passenger jet that ditches the fuselage and wing split to slash, drag, and revolutionize cabin layout. With space for approximately 250 passengers and a jaw-dropping 5,000 nautical mile range, Z4 promises up to 50% less fuel burn per passenger mile than today's jets, and United Airlines has already signed on for up to 200 of them. This all-wing design could turn every flight into a living room in the sky. Wider doors, multiple aisles, better cargo flow, all while fitting into today's airport infrastructure. Eurodrone. Europe's Eurodrone is a chilling vision of unmanned aerial dominance, a twin turboprop, long-endurance mail drone designed to stay aloft for up to 40 hours with a 2.3-ton mission payload. At a hefty approximately 12 to 13 tons MTOW and cruising around 500 kilometers per hour, 270 knots, this massive surveillance machine is packed with EO/IR sensors, AESA radar, and underwing hardpoints. Eurodrone is purpose-built to operate in civilian airspace alongside manned airliners, but its dual engines and stealthy sensor suite also let it serve in armed and ASW, anti-submarine roles, essentially merging spy drone and strike fighter tactics into one ghostly flying weapon. Centauri Valkyrie. The Centauri Valkyrie is a sleek, ultra-modern, four-seat canard pusher plane that blends luxury with raw performance. It cruises at over 230 knots, 430 kilometers per hour, has a range of 1,150 nautical miles, approximately 2,130 kilometers, and can carry over 1,000 pounds of useful load, all while operating at surprisingly low cost, approximately $200 per hour. Valkyrie's trailer-like front door and optional airframe parachute turn it into a flying spaceship of general aviation. Built for daring pilots who want a private jet experience without the private jet price tag. From electric planes to supersonic engines and even rockets the size of skyscrapers, the future of flight is arriving faster than anyone imagined. Which of these mind-blowing innovations do you think will truly change aviation forever? Drop your thoughts in the comments, And don't forget to like and subscribe for more future tech.